Hey guys, welcome back. This lesson is for Thursday, April 30th. We're going to be looking today at lesson 11.3, multiplying rational expressions. This is found on page number 414 of your book, so if you're not there, go ahead and open it up to page 414, multiplying rational expressions. Past couple lessons, we've dealt with these rational expressions, and we're going to continue to work our way through the different processes dealing with rational expressions. Today, we're going to look at multiplication of rational expressions. Now, remember what I said, our basic arithmetic procedures for dealing with fractions will also be used with our rational expressions, okay? So those basic arithmetic processes will still take place even with rational expressions, okay? So let's start by looking at our steps here for multiplying rational expressions, okay? Number one, we're going to factor. Now this may take place, we may have to factor our numerator or our denominator, or in some cases both our numerator and our denominator in order to do our canceling. So take a look at both your numerators and your denominators, and if there's something to be factored, then we're going to factor it, okay? So that's step number one. Step number two is to cancel. Just like in multiplying regular fractions, we cancel so that our answer becomes a little easier to find, all right? So we're going to do the same thing when we're dealing with these rational expressions, only in this case, we're going to factor first, and then we're going to cancel our common factors, okay? Now, step number three is multiplication, okay? So in multiplying, we're going to multiply our numerators with our numerators and our denominators with our denominators to find our answer, okay? So we factor, we cancel out our common factors, and then we multiply the remaining factors to find our new answer, our new fraction after multiplying. Now, the difference with rational expressions is in step number 4, we're going to have to take each canceled factor and set it factor, and what is my problem? Okay, so you set each canceled factor to equal 0. Now these are only our variables, okay? So factors that have canceled out that are variables we need to set to equal 0 so that we can state in our answer that those are not included in our domain, okay? They won't work for this problem. So in step number 5, after we set each canceled factor to equal 0 and we solve for that variable, in step number 5, we're going to write our answer and include excluded values. Okay, so all these excluded values that we canceled out before, that's going to be included in our answer, okay? So these are our steps for multiplying rational expressions. Now we're going to start off real easy with some examples that we're going to start off easy and work our way up here. So I have 5x over 3 times 6x over y, okay? Now, typically, if I had this, I would just say 3 goes into 6 2 times, so 2's left over. I've got no other variables that cancel out and no other numbers that cancel out. So I would say that this is 5 times 2 is 10. X times x is x squared over y. Okay, now let me explain this. If this helps you, you can also say 5x over 3 times 2 times, not 6, 2 times 3, and x over y. Okay, so if it helps you to break down your numbers into their factors in order for you to see what can cancel out, then do that, okay? It doesn't matter to me which way you do it just as long as you're getting the correct answer every time, okay? So if you can just look at this and say, okay, oh, 3 goes into 6 2 times, cancel that out, put 2 up there, and then you multiply across. Or if it helps you to see what your factors are and cancel them out, you can do either way. So my answer would be this. Now, let me point this out. We're not canceling out any variables here, so there's nothing to set to 0, okay? So for my step number 4, there's nothing to set, no factors to set to equal 0 as excluded values, okay? So in this particular step, we don't have to do that. So my answer would just be 10x squared over y. Now let's look at another one. I've got 4a cubed b over 3c times c over 2ab squared. Okay, now, again, I can write out my factors here if I want. 2 times 2 times a times a times a times b, and then 2 times a times b times b. You can write it out that way, or you can just say this. 2 goes into 4 2 times, and then I've got 1a here, cancels out an a, so I've got a squared, and then I've got this b cancels out, and I've got b down here. This c and this c cancel out, and everything is canceled out that I can cancel out, okay? So if it helps you to write these out, in other words, I could write this out as, instead of 4, I could write this out as 2 times 2 times a times a times a times b over 3c times c over 2 times a times b times b. So this is the same thing as this, is just expanded out so that you can see all the factors so that you can easily cancel. So this would cancel this out, 1a cancels out here, 1b cancels out here, leaving me with 2a squared times c, and then 3c times, or excuse me, this c cancels out with this c, 3b. Okay, so either one of these methods is okay, because they'll both get you the correct answer. But if it helps you to expand it out so you can see the factors, then go ahead and do that. There's nothing wrong with that. I've learned just to look at the numbers and cancel out the numbers, and that's perfectly fine as well. Now, in this case, okay, we do have factors that have been canceled out, okay? So we have to set these factors to equal 0. Now, I want you to notice that, give me just a second here. Hold on. Okay, sorry about that. Okay, so we're looking at our values to set them to 0, okay? So I'm going to start with a, okay? So I've got a here equals 0. A has been canceled, so a equals, I have to set a to equal 0. Now the next term I would look at, or the next variable, would be b. Now I am not going to set b to equal 0, and this is why. Because b is found in my final denominator, it is going to be a value that can be used in my domain, okay? So I am not going to set b to equal 0 because it is in the denominator of my final answer, okay? So any variables in the denominator of your final answer are not set to 0. Just the ones that you've canceled that are not in your final denominator. So a has been canceled. It's not in my final denominator. It's in my numerator, but that doesn't matter. It has to be in my denominator, okay? So if a is not in my final denominator, then and a has been canceled, then a equals 0, okay? Same thing with c. C is going to equal 0 because c has been canceled and is not in my final denominator. Okay, so hopefully that's understandable for you. Any variable that has been canceled during the cancellation process that is not found in your final denominator only, okay, has to be set to equal 0. If that variable is in your denominator, then you do not set it to equal 0. That is an acceptable value and is not excluded, okay? So my answer in this case is 2a squared over 3b where A does not equal 0 and C does not equal 0. Okay, so here's my answer. All right, A is excluded because A is not found. It was canceled out and not found in my final denominator. And C is equal to 0 because C was canceled out and not found in my final denominator. Okay, so hopefully we understand the difference there in that case. Okay, now let's look at another one. Here we've got 3x minus 6 over x squared plus 2x plus 1 times x squared minus 1 over 3. Okay, now my first step is always to factor. So I look at my first term here, and I can factor 3 out. Okay, so I'm going to say 3 times x minus 2. Okay, then I look at my denominator there. That can be factored into x plus 1 times x plus 1. Okay, then I look at my second term here, and I've got x minus 1 and x plus 1 over 3. Okay, so I factored everything out. This has been factored, this has been factored, this has been factored, and this cannot be factored. Okay, so I factored everything out, and now I go to step number 2, which is canceling my common factors. Okay, so 3 is common to 3. X plus 1 is common to x plus 1. So I'm left with this. I've got x minus 2 times x minus 1 over x plus 1. Okay, so here, this is going to be my final answer. I do not need to multiply or FOIL this out. This in and of itself is my answer, okay? I don't have to go x times x times 1, negative 2 times x, negative 2 times 1, and factor that out. It's not necessary, okay? So this is where we're at here, okay? Now, the difference here, okay, typically we would say, well, I should multiply, or I should, my next step would be to set to 0. But the problem with that is x plus 1 is the only thing that's been canceled out, but it still remains in my denominator. So because it's still present in my denominator, I can't set that to 0, okay, because it is part of my answer, all right? And then, of course, 3, we don't have to set to 0 because there's no variable there, all right? So this in and of itself is my answer because there is nothing that's been excluded completely from our denominator that we can set to 0, all right? So again, we only set terms, or we only set things to equal 0 that have been canceled out and are not present in the answer of our denominator, okay, or the denominator of our answer, all right? So that's the only time we set that to 0. All right, so that is the next one. Let's look at another one, okay, and as you can see, they're getting a little more complex as we go along here. But this should be not too difficult here. We've got x squared minus x minus 6 over 3x squared plus 18x plus 24 times 6x plus 24 over 6 minus 2x. Okay, now again, let me remind you that there can be more than one, or can be more than 2 fractions here. We can have 3 or 4 of them, but the same process will always apply. You're going to factor, you're going to cancel, you're going to multiply, you're going to set to 0, and then you're going to write your answer, okay? So all of those steps, no matter how many terms or how many fractions or expressions we have here, you're still going to follow the same steps, okay? So my next step, or my first step here, is to factor. So I factor this, and this factors to x minus 3 times x plus 2. And then 3x can be factored out of all of this down here, leaving me with x squared. Let's see, that's 9. No. Yeah. 18. Give me just a second here. Should have written this down. It's 6x and let's see. Oops. I believe that's 8. I think that's right. Yeah. Okay, so, and then 6x plus 24. 6 can be factored out, leaving me with x plus 4. And then here, now notice this, okay, this is like what we had before here, where we've got the x that has the negative, but before I switch this out, I can see I can factor out 2 out of each of these. So I'm going to factor out 2 out of each of these terms, leaving me with 3 minus x, okay, 3 minus x. Now, I am going to go a step further here. I've got x minus 3 times x plus 2, okay? And these two steps can be combined if you want to. Doesn't matter to me. I just wanted to lay them out so that you could see what numbers we're dealing with and how we get from one step to the other, okay? Then I've got, oops, not plus. I'll get it, guys. 6 times x plus 4, okay? And then I'm going to go ahead and remove my negative, okay? So remember, when we're moving negatives, the negative comes out, and every term in there gets swapped, okay? So now I have a negative 2 times x minus 3, okay? So notice how I did that. I took the x, or the negative, I moved it out, my positive 3 became a negative 3, my negative x becomes a positive x, okay? So we're extracting that negative, moving on the outside so that now we can have a positive x on the inside of there. Okay, so now everything has been factored out, okay? Now we're moving to our cancellation step, okay? So we're going to cancel. 3 goes into 6 2 times, okay? And then negative 2 goes into 2 negative 1 times, okay? And then we've got x minus 3 and x minus 3. And I've got x plus 2 and x plus 2. And I've got x plus 4 and x plus 4. Okay, now notice everything here has canceled out. Okay, I have nothing left except for a negative. So this is literally 1 over 1 times 1 over negative 1. Okay, this is the result of canceling these out. I go this, 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 this. Okay, they're all 1s except for this negative, which gives me a negative 1 down here. Okay, when in return ends up being negative 1. Okay, so this is the result, the product of my multiplication. All right, everything canceled out. Okay, so we've got just this one negative, which is 1 over negative 1, ends up being a negative 1. So we've got a lot to exclude here. Okay, we've got our x minus 3. We've got our x plus 2. And we've got our x plus 4. Okay, so x equals 3, x equals negative 2, and x equals negative 4. So my answer is negative 1, where x does not equal 3, negative 2, and negative 4. Okay, now let me explain this to you. Okay, let me just remind you of this. All right. Sometimes when you get these bigger problems, they look they look a little overwhelming, okay? Just remember that your steps will always remain the same, okay? So the first step is to factor. You factor anything you can factor in your numerator or denominator. Just factor it, okay? We're familiar with the factoring step by now. We have factoring down pretty well, okay? So all you have to do is just focus on factoring your first numerator. Okay, once you get your first numerator factor your first denominator, and then move your way through there till you factor everything out. Okay, then you're moved to canceling. Well, what are my common terms? I just cross out my common terms. Okay, or reducing your numbers down. We know how to reduce. We shouldn't have problems with that. Okay, and then after we cancel, then we multiply. Whatever's left, you just multiply. You go all the way across your numerators, all the way across your denominators. You don't have to refoil everything out. You just write them. If you have binomials, you just write them as binomials next to each other, indicating multiplication. Okay, and then whatever has been canceled out that is not still in your denominator in your answer, you just set to 0 and bam, you're done. Okay, so don't let these long problems trip you up. All right, the process is still the same on these, and you just got to work your way through them as you can. All right, if you have any questions on this or you didn't grasp something, this is when I wish we were in the classroom, because you could ask questions as we're going along. But if you hit something that you're not sure about, give me a call, shoot me a text. Email me, do something, but get a hold of me and let's get it straightened out, because this stuff is going to be on the quizzes, it's going to be on the test, your final exam. So make sure that we understand everything as we're going along there. Even the smallest thing, if you don't understand the smallest thing, call me, get a hold of me, and we'll explain it all. Okay? So for your homework today, we are going to do 7, 8, 13, 16, and 19. Okay, 7, 8, 13, 16, and 19 will be your homework for today. All right, and that will be due by the end of the day, Thursday, April 30th. All right, guys, 7, 8, 13, 16, and 19 are your homework. And again, if you have any questions, give me a call, get a hold of me, and let's get it worked out before we move on. All right. Okay, guys, that's all I have for you today. Get your homework done and get it submitted to me, and we will move on from there. All right? We'll talk to you guys later. Bye-bye.